A certain toll road averages 36,000 cars per day when charging $1 per car. The survey concludes that increasing the toll will result in 300 fewer cars for each cent of increase. What should the toll be charged to maximize revenue? Okay, so this is a perennial problem, right? If you raise the prices, you're making more per item, but you're selling less items. Supply and demand. So the question is, when do we reach that sweet spot when supply and demand meet? This is the most I can charge, and still sell the most. It's going to get me the most profit, because sometimes selling a little less, but for a little bit more, will get you more profit. You just got to decide where that point is. And that's what we're going to do. So the first thing we need to do is we might need to write a linear equation that gives us that how many cars we're going to get. So we're actually told right here, we're told the slope. We're told that there's 300 fewer cars per percent of increase. So in other words, negative 300, okay, cars per cent. Now, because we're in percent, anyways, stuck on that. This is 100 cents. So when I look at this point that they gave us, okay, so they gave us a point, and our points are cost and number of cars. So then our first cost is 100, and then 36,000 cars. So I can write an equation. I'm going to use my point slope, remember point slope, to write an equation because I have the slope and I have a point. So I'm going to do n y minus y1 equals mx minus x1, our old trusty point slope. So then y minus 36,000 equals negative 300 x minus 100. So then y minus 36,000 negative 300x plus, and let's see here, 1, 2, 3, 4. Okay, so then y equals negative 300x plus 66,000. Okay. By the way, this is how many cars would go on that road if it was free, because that's the y-intercept. Obviously, there's still only so many cars would travel it. So this is going to give me my number of cars. So this right here, remember, is cars. I want to maximize revenue. Revenue is cars times price, right? So if I charge $5, so for instance, that base one has a revenue of 36,000. It's $1, and we've got 36,000 cars. That's our price. That's our revenue. But we're varying this. So this is going to become the number of cars, the price, which is X, which whatever we set it, times this number of cars. So this is negative 300X plus 66,000. This is my revenue equation, okay? Now I'm going to distribute before I go any further, just because I want to make it easy to take my slope here. Now I'm going to take my derivative. So I get negative 600x plus 66,000. Okay. Now I want to know when this maximum, what's this price? So I'm going to set this equal to 0. So now I get 600x equals 66,000. And I divide and I get 110. So then that's cents. So that's $1.10. This is how much I should charge to maximize things. Now I could go back, I could use this, I could then find out how many cars that is, and I could find out the cost if I so choose. In this case, they just asked us what should we charge, but you could then go back and find the rest of the pieces if you were asked. Some of the problems ask problems, some of them only ask for a specific one. Make sure you're answering the question they asked. And so I always usually go back and go, okay, what was my question? In this case, what toll should be charged to maximize the revenue? I answered it should be $1.10 is what should be charged to maximize revenue. So again, it's just really important to be thinking, what did they ask and did I answer that particular question? It's really easy to get mixed up in all the other pieces and answer the wrong question.